Hey guys, welcome back. We were dealing with the alkenes and their reactions. We have studied one concept already that alkenes are hydrocarbons. And what was the general formula for the alkenes? The general formula for the alkenes was CnH2n. It means that all the members of alkenes family will follow this trend, will follow this general formula, and all the members of alkenes family will have at least one carbon carbon double covalent bond. Why we are saying carbon carbon? Because double covalent bond will be between the two carbon atoms. And afterwards, we have studied one more concept, and that was a saturation test for the alkenes family. We now know this thing that alkenes are unsaturated hydrocarbons as they have carbon carbon double covalent bond. This unsaturation means that they are going to attach, they are going to react with liquid Br2, and they are going to react, and after their reaction they are going to decolorize, discharge the color of liquid Br2 from red brown tone to a lighter shade, to a lighter color. Okay, right now we were dealing with the different reactions of alkenes family. Here you can see the one reaction was with the hydrogen gas. After reaction with hydrogen gas, an alkene is going to shift into an alkane. Okay, in all of these addition reactions of alkenes family, the double covalent bond, the double bond between the two carbon atoms will be shifted into carbon-carbon single covalent bond. Okay, I am mentioning the name of covalent bond here. Remember this thing, guys, that in complete organic chemistry, we are going to study only covalent bonding. Why it is so, guys? I have taught you already that bonding is basically of three types in your syllabus. One was ionic bonding, in which metal and non-metal were the partners. The second was covalent bonding, in which two or more than two similar or different type of non-metal atoms were combining with each other. So when we are talking about covalent bonding, it means that non-metal involvement is there. And in case of organic chemistry, as only non-metals are involved, that's why we can say this thing that only covalent bonding is involved in organic chemistry. Okay. Right now, in today's lecture, I will teach you, inshallah, related to halogens and the alkenes reaction and related to steam and alkenes reaction. Let's start. I am on this page right now. We are saying that this is an alkene, and after the reaction, alkene is going to react with halogen, and after the reaction, it is going to make a halogenoalkane. Halogeno alkane. This halogenoalkane thing is also called as haloalkane. Okay, so right now let's take an example. This is an alkene, its name is ethene. It is also called as eth-1-ene. Don't worry at all, I have told you already that I will give you 2 to 3 lectures on the naming topic only. So here, this is for example a halogen. Let's take chlorine, and after this reaction it is going to change its double bond into single covalent bond. Remaining hydrogens will be as it is. So this is Cl and this is Cl, and what will be the name? 1 comma 2 dash dichloroethane. So it should be in the same line. There was no space, that's why I have written like this. So it is a halogenoalkane. How the name is 1 comma 2 dash dichloroethane? The same answer I will explain you when I will teach you how to name all these compounds, how to give names to different organic chemistry compounds. We will discuss the rules for the naming, we will discuss the examples as well. Okay, by the help of Allah, inshallah, we will do that. I am right now on the next page, and I'm going to give you another example. You can see this thing that in this example there are 5 carbon atoms, and the 2 of the carbon atoms are attached with the double covalent bond, indicating the presence of an alkene. So there will be 3 hydrogens here, one here, one here, 2 hydrogens will be here, and the 3 hydrogens with this final thing as well. If, for example, we are going to attach it with fluorine, we are going to react it with fluorine. As a result, all of the carbon atoms will be remain as it is. Only the double bond will be shifted into single covalent bond. Remaining all hydrogens will be as it is. So you can see this thing that these two, which don't have all the hydrogens, which had the carbon carbon double covalent bond, is now going to shift into carbon carbon single covalent bond. So we can write it like this. Okay, I would like to write it with the red color so that you people may have a very clear idea. So here we are going to attach it like this. The two fluorines are going to attach with those two carbon atoms which had the double covalent bond. Okay, now you people can see this thing that this carbon atom is making a single covalent bond with this carbon atom. This carbon atom is making a single covalent bond with this carbon atom. This carbon atom is making a single covalent bond with this hydrogen, and this carbon atom is making a single covalent bond with this fluorine. Again and again, I am trying to bring your attention to the point that carbon atoms can make four covalent bonds. Carbon atom is a part of group number 4, and recall this concept which I have taught you while teaching you covalent bonding. Carbon atom has four covalent bonds in its outermost shell, so that's why carbon will make four bonds always. Okay, so this is the basic concept which you people need to know, and this is the basic concept which you people need to keep in your mind as well. Okay, so I am now going to finish this. Okay, before finishing that, I would like to give you one more example. Okay, let's have one more example. Okay, guys, let's see. This is an alkene as well, and in this alkene we had two covalent bonds. Okay, two double covalent bonds. Okay, remaining are the single covalent bonds. Again, this is a 6 carbon atom chain, and in this 6 carbon atom chain we can see that two of the carbon atoms are attached at one place with the double bond, whereas the two of the carbon atoms are attached with the double covalent bond at the other place. So this is these H2, this is this H, this is this H, and this is this H3. Okay, we are saying that we are going to react with Cl2. Now guys, there will be two Cl2s which will be required for this. Why it is so, you can see this thing. I'm going to explain this. 1 2 3 4 5 6, and the two carbon atoms which are attached with the double bond will receive the Cls. Okay guys, don't forget this thing that all the double bonded carbon atoms will be shifted into the single bonded carbon atoms. We can write the H2 here. We will write the whole number of hydrogen atoms as it is. And you can check this thing that nothing else has been changed. I am just pointing out very clearly this double bond is shifting into single covalent bond. This double bond is shifted into single covalent bond. So remember this thing that all those carbon atoms which are not attached with the double covalent bond will be remain as it is. The examples are in front of you. Okay, you can check this thing that those which don't have a carbon carbon double covalent bond will be remain unaffected after the reaction as well. So what are the changes when we are going to make an addition reaction of alkene? Number one change is that double covalent bond is shifted into the single covalent bond, and there is another change that across the double bond. What is across? This is across. This is across, guys. This is across. Please keep that thing in your mind. Okay, this is across. So this is across the double covalent bond. So please keep that thing in your mind that you are going to make this double covalent bond into single covalent bond, and across the double bond the newcomers are going to attach. As we have the single double covalent bond, I mean to say one double covalent bond here in the upper example, that's why we were requiring only 2F. And how we can have 2F from F2? Guys, I'm going to recall that concept in your mind right now. All the elements of group number 7, oxygen, nitrogen, and hydrogen, are naturally diatomic. Diatomic means that whenever we are going to write them, we have to consider the two atoms of them together. So F2, Cl2, Br2, I2, At2, and now tennessine is the last element of group number 7 as well. It will be also diatomic. Okay. Similarly, the elements like hydrogen, nitrogen, and oxygen will be diatomic as well. So that's why we are requiring 2Cl2 here. Why it is so? Because there are two double covalent bonds. I'm going to highlight those two double covalent bonds right now so that you people may have an idea. That's why we were requiring 2Cl2. We can require 4Cl2 if instead of two double covalent bonds, two double covalent bonds, there will be four double covalent bonds. Okay, so one double covalent bond is requiring two Cl atoms. Two double covalent bonds will require four Cl atoms. Four Cl atoms mean two Cl2. Six Cl atoms means three Cl2. So in this way, we can proceed our concept related to this. Now I am on the next page, and I'm going to give you the example of the last reaction of alkenes, and that is the reaction of alkenes with with steam, with water in the gaseous state. Why it is steam? Because the temperature for this reaction will be higher. That's why the water is changed into the steam form. Let's make the compound on the next page. I am on this page right now. Okay, guys, you can check this thing. It is the reaction of an alkene with steam. Okay, before moving ahead, I would like to bring your attention to the basic concept, that is the conditions for this reaction. Don't forget this thing, that there are specific conditions for this reaction. And what are those? Number one is 300 degrees Celsius temperature, which you are going to require for this reaction. Number two is 60 atmospheric pressure, which we are requiring for this. Okay, 60, it means that two zeros are more here, and it is called as kilopascal. Guys, don't forget this thing, that examiner is asking the question in the atmospheric units and in the kilopascal units as well. Okay, kilo means obviously the two more zeros will be, three more zeros will be added over there. So you know this thing, that if it is in the pascal thing, so what will be there? 60 and this and 1 2 3. Okay, and then this is called pascal. So instead of writing in the pascal, I would like to suggest you that you are going to write in the kilopascal and in the atmosphere as well. Okay, so guys, again and again, I'm trying to keep this thing in your mind, that examiner can ask about pressure in the units of atmosphere and in the units of kilopascal as well. Specifically in IGCSE, examiner is giving the spaces to write the units of pressure in kilopascal only. Sometimes they are asking an atmosphere as well. So please keep both the units, both the measurements in your mind. Okay, now pressure and temperature are mentioned. The third thing which is left is the catalyst. And what is the catalyst for this reaction? It is H3PO4. What is that? It is called either hydrogen phosphate, or the number two name is phosphoric acid. I am mentioning the name here, phosphoric acid. Okay, guys, let me inform you that this is an alkene. So this is an alkene I am writing here. It is the structural formula in which all the bonds are shown. It is called as a displayed formula as well. So here I'm writing H2O. It is in the form of steam, so I'm writing gas. So this is one carbon, second carbon, all the hydrogens will be as it is. I will write down the added ones with the red color. One of the carbon will receive H and the other carbon will receive OH. Don't forget this thing, that steam water has two parts. One of them is H and the other of them is OH. So one carbon will have H and the other carbon will have OH. In this way, the alkene will be shifted into alcohol, So guys, don't forget this thing, that the carbon chain having OH group attached with it, it is called an alcohols family. We will study about alcohols family in detail. After this example, I will give you the next few more examples related to alcohol formation from alkene, explanation of this topic, explanation detailed, and the examples of this topic will be given to you in the next lecture, inshallah. Take care of yourself. Thank you.